All right, today we are cracking open one of the biggest prehistoric cold cases out there, the story of how the largest predator to ever live just vanished. Let's dive in.
So, why did it vanish? It's a huge question, right? You've got this creature that absolutely dominated the oceans for millions of years, and then, in what's really a geological blink of an eye, poof, it's just gone. The question is, what happened?
Okay, just look at this absolute unit. This is Otodus megalodon. We're not just talking about a big shark here. This was a legitimate sea monster, a true apex predator that would make a great white look tiny. And its vanishing act is one of the greatest mysteries in all of paleontology. To figure this out, we've got to put on our detective hats. We're sifting through clues that are millions of years old, trying to figure out what in the world could take down a titan of this scale. Think about it. For ages and ages, Megalodon was just there, a fixture of the ancient oceans. And then you look at the fossil record, and the trail just goes cold. It stops. This wasn't some slow fade into the night. It was an abrupt, dramatic exit. And that right there is the core of the whole mystery. So you might be asking, why is this so tough to crack? Well, it comes down to the evidence, or more accurately, the lack of evidence. What we have to work with is, let's just say, frustratingly incomplete. You know, this quote from fossil collector Gordon Hubble, it just hits the nail on the head. He describes it as trying to figure out a movie's plot from a few scattered, warped snapshots. I mean, can you imagine that? Trying to understand the whole story from a couple of random, blurry pictures? That's exactly the challenge scientists are up against. Now, what you're seeing on screen, this is basically a paleontological miracle. See, sharks are mostly made of cartilage, not bone. And cartilage, well, it just doesn't like to fossilize. So finding a complete ancient skeleton like this one, it's not just like finding a needle in a haystack. It's like finding a needle in a haystack the size of the entire planet. So the reality for paleontologists is this. Teeth. That's pretty much it. The main evidence we have for Megalodon is its teeth. Now sure, they're super hard, incredibly durable, but an entire animal is so much more than just its mouth, right? We're trying to piece together its whole life, its diet, its extinction, all from these scattered fragments. Okay, so to get a handle on Megalodon, you gotta understand its family tree. We're talking about the lamniformes, also known as mackerel sharks. And let me tell you, this is one diverse family. It's got a real rogues gallery of sharks, some famous, some just plain bizarre, that are still swimming around today. I mean, the range here is just wild. On one hand, you have the iconic great white, a perfect, streamlined predator. And on the other, you have, well, the goblin shark, which looks like something straight out of a deep-sea nightmare. And somewhere right in the middle of this crazy family tree, that's where you find our star, the mighty Megalodon. But let's go back to those teeth for a second. It turns out they're not just fossilized fragments. They're actually tiny little time capsules. And scientists have just figured out a brand new forensic tool that can unlock secrets that have been sealed inside them for millions and millions of years. All right, before we dive into the nitty-gritty science, there's one key idea we all need to be on the same page about: trophic level. It sounds complicated, but it's really simple. It's just your position on the food web. You know, if you're eating plants, you're on a low level. If you're eating the plant eaters, you're a step up. And if you're the apex predator eating other predators, well, you're at the very, very top. Okay, so here's the cool part. It all comes down to zinc. When a shark eats its prey, it absorbs zinc. That zinc then gets permanently locked into the super hard outer coating of its teeth, the enameloid. Now, scientists can measure the ratio of different stable isotopes of that zinc. And here's the key takeaway, the one thing you need to remember. The lower the zinc isotope value they find, the higher up on the food chain that shark was. Simple as that. And here's the absolute best part. That enameloid is so incredibly tough that this chemical signature is still there, perfectly preserved, even after millions of years. It's like a message in a bottle from the ancient oceans telling us exactly what these things were eating. So, what did the scientists do? They took this brand new technique and used it on the teeth of Megalodon and on the teeth of another very famous shark that was swimming around at the very same time. And what they found, well, it pointed to a clash of titans. The results were Honestly, they were stunning. What they saw was that back in the early Pliocene, you had Megalodon and the brand new, just evolved great white shark swimming in the exact same oceans. But the zinc analysis showed something incredible. They were eating at the exact same trophic level.
Just let that sink in for a second. They weren't just sharing the same zip code. They were direct rivals. The data points to one thing. They were hunting the same food, which put them in a head-to-head competition for survival. And boom, right there we have our first massive clue in this extinction cold case. You've got two top predators, you've got a motive, survival, and you've got opportunity. They were sharing the exact same hunting grounds.
Let's just lay out the timeline here, because it's pretty damning. For millions of years in the Miocene, Megalodon is the undisputed king of the ocean, no contest. Then the Pliocene rolls around, and the great white shows up. And it's not starting at the bottom. It immediately starts competing at that same top-tier trophic level. Then, fast forward to the end of the Pliocene, and Megalodon is gone. Vanished. The timing is just impossible to ignore.
Now look, other things were probably going on, right? Climate change, for sure. But this new evidence points to a really powerful potential driver for the extinction. Good old-fashioned competition. The arrival of a smaller, maybe more nimble, more adaptable predator going after the exact same food, that could have been the one thing, the final push that knocked the giant off its throne for good.
And all of this leaves us with one last really fascinating question. In a high-stakes battle for the resources of an entire ocean, was there only room for one winner? Maybe, just maybe, the world wasn't big enough for the both of them. Because in the end, there was a survivor. The great white shark didn't just make it through this prehistoric showdown, it thrived. It's still out there today, ruling the oceans. It's like a living echo of that ancient war, and a pretty stark reminder that it doesn't matter how big you are. Even the mightiest can fall when a new challenger steps into the ring.